polygons to be congruent, all their corresponding parts have to be congruent. So remember, the difference is that figures can have curves, polygons cannot. So in your last two homework assignments, if you wanted to prove that two triangles were congruent, you had to make sure in your proof that you had listed all three pairs of sides and all three pairs of angles. You needed all 6 things to be congruent. Today, we're going to basically go through 2 shortcuts on proving triangles congruent. You no longer have to show 6 things, you just have to show me 3. You will have a total of 5 shortcuts proving triangles congruent, and today we're going to do 2 of them. Wednesday we'll do 2 of them, and then next week we'll do the 5th one, right? At the top of your 4.2 notes are the 5 ways to prove triangles congruent. I'm just going to give you a preview of them. The first one is called the side, side, side postulate, and it works in the fact that if 3 sides of one triangle are congruent to the 3 sides of the other triangle, then the 2 triangles are congruent. So you don't have to show me anything about the angles. You just have to say that the 3 sides of the first triangle are congruent to the 3 sides of the second triangle, and then they're congruent. Second one, side angle side postulate. 2 sides and the angle between them have to be congruent to the 2 corresponding sides and angle between them, and then the 2 triangles are congruent. Side, angle, side. The angle is between the 2 sides, hence where the A is between the 2 S's. Side, angle, side. Those are the 2 that we're going to look closer at today. Wednesday we'll look at these next 2. Angle, side, angle. You have 2 angles in the side between them congruent to 2 angles in the side between them. If you can show that the 2 angles in one side are congruent to 2 angles of another, then the triangles are congruent. You don't have to show me anything else. Wednesday we'll do this guy. Angle, angle, side. Again, 2 angles in a side, but this time the side is not between the 2 marked angles. And look at your letters. A, S, A. The side is between the angles. Angle, angle, side. The side is not between the 2 angles. And then the 5th way to prove 2 triangles congruent is called the HL theorem, and that stands for hypotenuse leg. And we will do that one next week also. Okay, so kind of want to think of these as shortcuts. You don't have to show all 6 things, you just have to show 3 now. To look at those 2 postulates that we're going to look at today, you have them at the top. Side, side, side. If 3 sides of one triangle are congruent to the 3 sides of another triangle, then the 2 triangles are congruent. So if you can prove that the 3 sides are congruent, then you're done. You don't have to tell me anything about the angles. On yours, you have a little triangle congruency statement. If I call the first triangle GHF, maybe you did it differently already, but that's okay. Bless you. We just have to make sure we line them up correctly. So angle G in the first triangle is congruent to which angle in my second triangle? P. Good. G is between the 1 tick mark and the 3 tick mark. So if I go over here, the corresponding angle has to be between 3 and 1. How about H? Which angle is that one congruent to? Q, and then it'd have to be R. Congruency statement. Side, angle, side. Our second way to prove triangles congruent. If 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. The word included means between. So angle C is between the 2 marked sides. That's where those 2 congruent sides meet. Angle D is between the 2 congruent sides. It's where those 2 sides meet. So included means between. Since I have those 2 angles congruent plus the 2 sides around them, then I can say the 2 triangles are congruent by side, angle, side. Let's name the first one triangle CBA. Then lining up corresponding parts, angle C is congruent to which angle? D, good. And B goes with F, and then lastly, E. Two ways to prove triangles congruent. Side, 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 angle, side. If you can't match those up, then the 2 triangles won't be congruent. All right, so our first example is a proof. Given M is the midpoint of segment XY, Segment AX is congruent to segment AY. They want us to prove the two triangles are congruent. First step in a proof, given. Copy that down. Make sure you copy all of it. Sometimes the givens get kind of lengthy. You don't want to miss any part of it. After we write it, then what do? Yeah, mark it on your picture. So M is the midpoint of segment XY. How do we mark that? What does it mean to be a midpoint? Be in the middle, so then I have two equal sides. M is the midpoint of segment XY, so it's right in the middle. Therefore, XM should be congruent to MY. That's how you mark midpoint. Then the second part says that AX is congruent to AY. We're trying to prove that triangle AMX, the one on the left side, is congruent to triangle AMY, the one on the right side. You have two ways, side, 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 or side, angle, side. Why side, side, side? Good. The middle segment has to be congruent to itself. They both use it, and it's the same segment. So when I look at my markings, side, side, side is very visible. You have to make sure that you have all three pairs of sides listed then. So right now, when I look at my proof, we only have one pair of sides listed congruent. I need to list the other two. What do you want to put for the second one? AM is congruent to AM. Okay, that would be that one in the middle. And that's your reflexive property. Good. There's two of the three pairs. XM is congruent to MY. Those are the little ones on the bottom. How did we know that those little ones on the bottom are congruent? Because of the midpoint, definition of a midpoint. We now have all three sides listed. So our last step is what we were trying to prove, that the two triangles are congruent. So number 4, you're going to copy down what it says there. Triangle AMX is congruent to triangle AMY. And that's by side, side, side. Don't worry about writing postulate or theorem behind them, just side, side, side. Questions on the first proof? Okay. Number 2 then. What other information do you need to prove that triangle ADC is congruent to triangle BCD by side, angle, side? Okay, the triangles are overlapping and creating more triangles. I'm going to pick apart the two that they want us to look at, ADC and BDC, or BCD, excuse me. So ADC is that guy. And then BCD, I don't know, something like this. And it's marked on there that the length or the segment AD is congruent to segment BC. And they're trying to figure out what else we need in order to prove that those two triangles are congruent by side, angle, side. Do we need that or do we know that? DC congruent to DC. Wouldn't we know that? Yeah, because it's the same segment. If you look at the overlapping picture, triangle ADC, and then triangle BCD. They overlap along segment DC. They both use it. It's the same thing. So we know that DC is congruent to itself. We know that. But then what do I need to prove that the triangles are congruent by side, angle, side? Do I need a side or an angle? I need an angle, right? Because I have the two sides of side, angle, side. And we need it to be the angle between the two sides. So which angle is marked between AD and DC? D. And which angle is between BC and DC? C. So when you look at them as two separate triangles, you could write we need angle D congruent to angle C. You kind of have to be careful if you look at it as the overlapping picture. Angle D is this whole thing. So you should really say angle ADC congruent to this whole thing, which is angle BCD. Depends on how you look at it to name them. Anytime there's vertical angles, that's not something you need. That's something you already know, that those angles are congruent. If they ever have a shared side, like number 1 and number 2, you know those segments are congruent. You wouldn't necessarily need that. And those are the two things you look for when you're doing these proofs when you're stuck. If you come to a part in your proof and you're stuck, look for vertical angles or look for that reflexive property that might help you get on the way. All right, number 3. Given angle RSG is congruent to angle RSH, segment SG is congruent to segment SH, they want us to decide if we can prove that triangle RSG is congruent to RSH. So we're not writing a proof, we're just using this given information to conclude if we can actually prove that or justify that. Mark your picture based on the given. Angle RSG. RSG, that would be that bottom left side. Remember, it's that middle letter, that's your vertex. Angle RSH is the right side. And then they tell us that SG is congruent to SH. From that given information, can we conclude that triangle RSG, the one on the left, is congruent to triangle RSH, the one on the right? Why so, Jack? The side, angle, side, but I only have two sides marked. Good. They are sharing segment RS, so that's got to be congruent to itself. And when you mark your reflexive step, then you can see it goes side, angle, side. From the information, can you prove? Yes. Explain. Side, angle, side. You could even write on there that RS is congruent to RS by the reflexive property. Just to beef up your explanation. On your homework, when they ask you to explain, sometimes it's as easy as just writing either side, angle, side, or side, side, side. You may not have to write a complete full sentence of, because these angles are vertical angles, therefore those angles are congruent and da-da-da-da-da. It's just using what you know. Most of you already flipped it over. Go ahead and copy down your given on number 4 and see what you can come up with. See if you can prove that proof. All right, so after you have your given copied down, then you mark your picture. HF is congruent to HJ. Guys, I'm talking now. Thanks. FG is congruent to JK. And then it says H is the midpoint of GK. Make sure you check your whole given to make sure you have it all written down. If H is the midpoint of GK, then GH should be congruent to HK, which is what you need to write on your second step. GH is congruent to HK, and this would be by the definition of a midpoint. Now your picture shows side, side, side. You have to double check that you have all 3 sides in your proof, which you do then. So then step 3, you're going to write triangle FGH is congruent to triangle JKH by side, side, side. Okay, you have to make sure you have all the parts in your proof. Can't skip anything. questions on that proof? Neat. We're going to skip number 5 and go to 6. From the given information, can you prove that triangle AEB is congruent to triangle DCB? And then it says to explain. So given, it's written there in handwriting for you. AE is congruent to DC, and EB is congruent to CB. Do we know anything else in our picture? Angle CBD? Angle CBD is congruent to angle ABE. You guys agree with them? Because they're what kind of angles? Vertical angles. Good. That's, yeah, those angles, CBD and ABE. He's just using his 3 letters. Do we have any parallel lines that we need to look for congruent angles? No. Does it say anything about a point being a midpoint of something else? No. Okay, so this is all we can get from this diagram. So then they're not congruent, but I have a side, an angle, and a side. Good. Your congruent marked angles have to be between the 2 congruent marked sides. It's got to be the included one. One way you can tell, if you highlight the 2 sides that are marked congruent, where they meet, that's the angle you want, because that's the angle between them. I don't have angle E marked, so therefore it can't be side, angle, side. So can you prove? No. Explain? We'll say the included corresponding angles are not congruent. We need those included angles to be congruent to each other. And it's definitely not side, 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 because we don't have all 3 sides. All right, 7 and 8. 7 says in triangle FGB, which sides include angle B? Or I could reword that and say, angle B is included between which 2 sides? We're trying to figure out which 2 sides sandwich angle B. Or, yeah, sandwich angle B. Draw a picture. Draw triangle VGB. Here's angle B. Which 2 sides are on the outside of it? Or angle B is between which 2 of those sides? Or which 2 sides meet at angle B? VB. And what else? GB. Good. Those 2 sides sandwich. I don't know how else to describe that. They sandwich angle B. They're on the outsides of them. Angle B is between them. It's where they meet. So we'll say side VB and side GB. It's basically the 2 sides that make up that angle. Number 8, in triangle STN, which angle is included between NS and TN? This time we're trying to find the angle that goes between the 2 sides. STN. And we're looking between NS and TN. Which angle is between them? Angle N. It's where they meet. It's what they have in common. If you look at the segments, they both have an N. That's the angle between them. Questions on between? Included? Okay, when you get to those ones in your homework, draw a picture to help yourself out. 2 left. Number 9. Sorry, I don't have the rest of your picture labeled. The far right triangle, you need a Y on the top and an X on the bottom. It says, which triangles can you prove congruent? And tell whether you would use the side, side, side or side, angle, side postulate. Can we use side, side, side? AB is not congruent to YX. Okay. Could I use side, angle, side? How? Why? Vertical angles, good. When you mark those vertical angles, then you can see that it's side, angle, side. It's the angle that's between the two sides. So when it asks which triangles, let's write a congruency statement. I'm going to name the first one triangle APB. Now you have to make sure you line up the congruent corresponding parts. So angle A, since that one came first, is congruent to which angle of the other triangle? Is it X or is it Y? It's X. Good. Angle A is on the side with one tick mark. Angle X goes with the one tick mark. So those two would be the corresponding. And then P is obviously congruent with P and then Y at the end. And we use the side, angle, side postulate. You have to watch the triangles. They flip them, turn them, twist them. All right, last one, number 10. Kilgore, Riley. Can you prove that triangle SED is congruent to triangle BUT from the information given? Remember, you only have two ways to prove triangles congruent. It's either going to be side, 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 or it's going to be side, angle, side. Why not? Good. It's definitely not side, 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 because we don't have the third side. But it's also not side, angle, side, because my two sides that are marked congruent does not have the angle between them marked. It's not the included angle. And same on triangle BUT. The two sides that are marked don't give me the included angle. So can you prove? No. Explain. We'll just say the same thing we did before. The included corresponding angles are not congruent. You would need angle S congruent to angle B to prove them congruent by side, angle, side. All right, questions on side, 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 or side, angle, side? All right, you have 20 minutes here to get started on your homework. Remember, if you have to write a proof, then you need to draw the picture down with it, okay? There's about 5 proofs on today's homework.